Hello everyone, welcome back to Deeksha Vedantu Foundation channel, and today I am going to discuss the sample paper 7 physics part. Chemistry and biology is already discussed, and if you have missed that, then you can obviously not following our channel, you have not subscribed to our channel. Definitely you have to subscribe to our channel, join our WhatsApp group so that you get all the updates from whatever we are doing. The sample papers are already shared in our channel, so if you have missed that, you can see that. Now let's see the paper analysis. Paper analysis says that total marks is 25, 4 objective questions, 3 2 marks question, 2 3 mark question, 1 5 1 4 mark question as usual, right? So let's start with the section 1, that is MCQ. At what distance from a convex lens should an object be placed to get an image of the same size as that of the object on a screen? So we have a convex lens, right, and we know that in case of mirror, concave mirror, we have to put it on the 2f to get a same size of the object, right? That is the center of curvature. In case of lens, we do not have something called center of curvature, but the distance is remains same, that is 2f. If you put the object at 2f, you get a equal size of image which is formed on the other side of the lens, real inverted but same size. Magnification is -1. So at the twice of the focal length of the lens is the answer. Easy question. Without wasting time, I do not want to over explain things, so that the answer remains crisp and clear. The lens system of human eye forms an image on a light sensitive screen which is called as cornea, ciliary muscles, optic nerves, retina. The sensitive screen where the image is formed and because of which you are able to see me and I am able to give this lecture to you is because I have a retina, you have a retina. The image of me is formed inside your retina, and your optic nerve carries the information to your brain, and that is why you can see me, right? Next, another interesting question: the pattern in the magnetic field produced inside a current carrying solenoid. Very important. Inside a current carrying solenoid, we know that inside a current carrying solenoid the magnetic field is constant, and constant magnetic field is represented by parallel lines, that is option A. So answer is option A. Very careful, do not miss with option C or option D. You might think, okay, in a solenoid we get pattern like this, so maybe this is the correct answer. No, inside the solenoid, when you are considering inside the solenoid, you don't need to consider anything which is outside. Only what you need to consider is whatever is inside. So inside a solenoid, okay, the field lines are, suppose this is a solenoid, okay, inside the solenoid the field lines are parallel and constant, that represents the constant electric magnetic field inside the solenoid. That is why it will be parallel lines. Very careful. Now assertion and reason. The rainbow is a natural spectrum of sunlight in the sky. Rainbow is formed in the sky when the sun is overhead and water droplets are also present in air. Okay, overhead. So overhead is not the correct thing. First of all, obviously this is not the explanation as well. Maybe it was a correct statement if it was behind the head. Okay, the sun has to be behind the head. Overhead means during the noon time. Noon time it does not happen. It generally happens in the afternoon or in the evening, just before dusk. You can see rainbow. I have said multiple times. So only A is true but R is false. Okay, so rainbow is a natural spectrum of sunlight. Yes, spectrum means 7 colors of light, right? 7 colors that is present in white light, and rainbow definitely is a natural spectrum of sunlight because sunlight splits into its 7 constituent colors. Some of them are a little stronger, some of them are little weaker, but you can definitely see at least 3 to 4 colors in a clear day rainbow, and if you observe it very closely, you can definitely find all 7 colors present in the rainbow, right? So rainbow is basically the natural spectrum, which is a correct statement, but sun need not to be overhead, it has to be behind the head. Sun needs to be behind the head, and obviously water droplets are also present in here. Water droplet part is correct, but overhead is not correct. Now next question, next part, question 2 mark question. Let's see this question. An object is placed at a distance of 10 centimeter from a convex mirror of focal length 15 centimeter. Find the position of the image formed by the mirror. 2 mark question, easy question. So convex mirror means focal length is positive. Okay, you have to remember convex lens, convex mirror. Okay, if this is convex, it is always positive. It is concave, no matter mirror or lens, it is always negative. Object is placed at a distance 10 centimeter. Object means object distance is always negative. Okay, object distance by default is negative. Now we have to use the mirror equation. What is the mirror equation? 1 by v plus 1 by u equals to 1 by f, or 1 by v equals to 1 by f minus 1 by u. Usual trick, f u minus f, right? So v equals to uf divided by u minus f. This is the formula. If you remember this formula, it is easy. Otherwise you can obviously derive it, easy to derive. Now put the values. V equals to u is minus 10, f is plus 15 divided by minus 10 minus plus 15, that is 15. Okay, so it will be minus 150 divided by minus 25. Both are minus, both minus means values will be added and sign will be negative, right? So minus minus cancels, it will be 25, that means I think 4, 5, 6, right? So it will be 6 centimeter. Okay, so object will be 6 centimeter. It's a virtual image, that is why it's on the other side of the mirror, right? It's a mirror, so plus means virtual image. Now show how would you connect 3 resistors of each resistance 6 ohm so that the combination has a resistance of 9 ohm. Okay, 3 resistors each 6 ohm. 3 resistors are there, each of them are 6 ohm, so that the combination resistance is 9 ohm. Also justify your answer. Okay, and there is a circuit given. Okay, this is a CBSE question paper. Obviously this question was very popular, many students were not able to answer this. In the given circuit, calculate the power consumed in watts in the resistor 2 ohm. So they asked you what is the power consumed in this 2 ohm resistor. Let's see. So first, to achieve a total resistance of 9 ohm, connect 2 resistors in parallel and then connect the third resistor in series with the parallel combination. With this you have to add one more calculation. When 2 resistors are connected in parallel, that is 6 into 6 divided by 6 plus 6. So what is the equivalent resistance? 6 by 2, that is 3 ohm. Now you connect, so 2 resistors are connected in parallel and one is connected in series. If you draw this circuit diagram also, you will get marks. Okay, but you have to do the mathematics to show that these 2 6 are actually giving you 3 ohm and another 6 is giving you plus 6 ohm. So total resistance is 9 ohm. Mathematics is required to get full marks, otherwise they will deduct some marks. This is a 3 mark question. Obviously the circuit has a 6 volt source with 2 resistors, R1 is equal to 1 ohm and R2 is equal to 2 ohm connected in series. Okay, calculate the equivalent resistance. So here we have a 1 ohm and a 2 ohm connected in series. What is the total resistance? Very simple, series connection, 3 ohm, right? 1 plus 2, 3. What is the current in the circuit? What is the formula for power? First of all, we have to remember the formula for power. When resistance is known, okay, formula for power is basically I square into R. If resistance is known, whenever you are trying to find the power consumed in a resistor, only thing that you can do is to use this formula I square R. When voltage and current are known, simple formula, power is equal to VI. Otherwise, when resistor, whenever you are trying to find power through a resistor, the formula is I square R, right? So first we have to calculate the R, sorry my mistake, you have to calculate the current I, current in the circuit. Okay, how to do that? Current in the circuit is very simple. Voltage divided by equivalent resistance. Voltage divided by equivalent resistance, that is 2 ampere. So 2 ampere current is flowing through each of the resistor. So what is the power consumed by this? So 2 square into 2. 2 square into 2, that is 8 watt. Unit is very, very important. If you miss out on unit, 0.5 marks will be deducted. Very important, right? So I square R is the formula. So I square means 2 square. This is 2, and resistance is also 2 in this case. So it will be 4 into 2, that is 8 watt. Power, unit of power is watt. Okay, unit of energy is joules. So you have to remember, whenever if they are asking you to find the energy, unit should be in joules. If they ask you to find the power, unit will be 8 watt. So the power consumed in the 2 ohm resistor is 8 watt. What is the power consumed in 1 ohm resistor? Suppose, so it will be I square R. In this case, I square is 2 square and R is 1 ohm. So it will be 4 watt. So this one is consuming 4 watt. This is not part of the question, but I just did it so that in case you are confused how to do that for other resistances, this is the way to do it. Now, two magnetic field lines do not intersect each other. Why? Easy question. How is a uniform magnetic field in a given region represented? Draw the diagram in support of your answer. Okay, so let's see. Magnetic field lines never intersect each other. Why? The reason is because the point of intersection, the magnetic field lines would have two different directions, which is not possible. We know that in a space of region, whenever there is a magnetic field, each point has an unique direction. Each point has an unique direction. One point, two different direction is not possible, right? So it has a unique direction. So because of that, if two lines intersect each other, magnetic field lines, suppose this is in this direction, this is in this direction. So at the point of intersection, you will get one direction along this line, one direction along that line. So that means at this point of intersection, you would have two different distinct direction, which will violate the law that states that magnetic field will have only one direction, unique direction at every point. That is violated. So that means this is not possible. A uniform magnetic field is represented by parallel and equally spaced lines. Okay. So parallel and equally spaced lines, you have to draw the diagram as well, even though slightly this line is not slightly parallel. Okay, so you have to draw the diagram as well. This indicates that the field strength and direction are same at every point. Field strength and direction are same at every point. Okay, now next, okay, 3 marker. Okay, so that question was 2 marker question. So that was a longer question, considering that was a 2 marker question, that circuit diagram question. Anyway, if that was only one part, say only the second part or only the first part would have made sense. But anyway, they are trying to give you the lengthy question nowadays. This is directly from your question paper. I think 2022 or 2023 question paper this is. Okay, so they are slightly giving you a lengthier question paper so that it takes some time to solve. Okay, name the defect of vision represented in the diagram. So what is the name of this defect? Obviously we know that hypermetropia. List 2 causes of hypermetropia, farsightedness. Now they are asking the same question. With the help of a diagram, show how hypermetropia is corrected. Let's see. Diagram you can check in your book. Okay, convex lens is used, very common diagram. So diagram is not included in this lecture. I have discussed it in my chapter wise lecture as well. The defect of vision shown is hypermetropia or farsightedness. This occurs because the image is formed behind the retina. So image is forming behind the retina. The near point of the person is further away from the normal point, that is 25 centimeter. For a normal person, the near point is 25 centimeter, but it moved away that means now it is more than 25 centimeter. Be careful, it is not less than 25 centimeter, it is more than 25 centimeter. So the near point, this is called near point, the nearest point where we can see the object. Okay, if the distance is more than 25 centimeter, you cannot see any object at 25 centimeter, that means you are suffering from hypermetropia. So when reading books, if you are not clearly see that book, definitely you are suffering from hypermetropia. It is advised for you to consult a doctor. The near point of the person away than the normal near point, that is 25 centimeter, making it difficult to see nearby objects clearly. The two causes of hypermetropia are focal length of the eye lens is too long, that means eye lens is weakened. Okay, the eye lens is weakened, it cannot focus closer objects to your retina. So focal length is too long, focal length increases means power decreases, so power of your eye is decreased. The eyeball has become too small, or what happens, possibly normal eyeball, say normal human has this big eyeball, but somehow because of some defect your eyeball is now reduced. So previously the rays were able to concentrate here, but now again they are concentrating here, but your eyeball is now reduced, so again it is falling behind the retina. So that is the another reason, eyeball has become too small, causing the image from the behind the retina. That is why it is said that do not watch TV or mobile phone from up too close, otherwise it might harm your retina, it might harm your eyesight. Okay, you will suffer from defect like hypermetropia. Or if you cry too much by putting your head inside the pillow, that is also a possible reason that you may have a hypermetropia. Okay, now hypermetropia is corrected using a convex lens. The convex lens converges in incoming light rays before they enter the eye, so the image is formed in the retina. Okay, now explanation, you have to mention these points while drawing the diagram. Okay, what are those? Near point of the hypermetropic eye, that is you have to mention near point. This is the normal near point. Now after the recedence, this is the for a human eye, normal human eye, standard human eye, he can see objects here. So this is the 25 centimeter distance, but it is receded to say another distance greater than say 35 centimeter. This is not exact value, say, so it is receded away, right? Now what else? Near point of a normal eye. So near point of the hypermetropic eye is the capital N, near point of the abnormal eye is N dash. The convex lens brings the light rays together to form a clear image at the retina, thus correcting the hypermetropia. Okay, so the diagram has to be drawn. Okay, they have given the explanation, but you have to draw the diagram. Name and state the rule to determine the direction of the magnetic field produced around a current carrying straight conductor. So you have to name and state, both you have to do. For what? For finding the magnetic field produced around a current carrying straight conductor. Okay, if not force, do not confuse. Current carrying straight conductor, only one rule is there, right hand thumb rule. Okay, force experienced by a current carrying straight conductor placed in a magnetic field which perpendicular to it. Name and state the rule to determine its direction. Again, the name of the rule is Fleming's left hand rule. So be careful. Let's see. First is right hand thumb rule. Okay, so according to this rule, if the thumb of the right hand points in the direction of the current, curled fingers show the direction of the magnetic field around the conductor. So if this is the current, your curled fingers points the direction of magnetic field. It's a circular line, we know that it's a circular line, so curled fingers perfectly represents the direction of magnetic field. The rule is Fleming's left hand rule. According to this rule, stretch the forefinger, middle finger and thumb of the left hand mutually perpendicular to each other. Forefinger points the direction of magnetic field, middle finger points the direction of current, then thumb represents the direction of force. So if you place a current carrying conductor in a magnetic field, okay, if then it will experience a force. What is the direction of the force? That direction of the force is given by Fleming's left hand rule. So your forefinger will point the magnetic field, your middle finger will point in the direction of current, then your thumb will represent the direction of force. Okay, this is the Fleming's left hand rule. What else? Now let's move into the 5 marker question. The 5 marker question in this paper is little longer. Let's see part A, 36, part A 1. Okay, define electric power. Express it in terms of potential difference V and resistance R. An electric oven is designed to work on the main voltage of 220 volt. This oven consumes 11 units of electrical energy in 5 hours. Calculate the power rating of the oven. Now B, C, we have part 2 also has 3 parts, A, B, C. Calculate the current drawn by the oven. Calculate the resistance of the oven when it is red hot. Okay. Now let's see 36b. Write the relation between resistance R and the electrical resistivity rho of the material of the conductor in the shape of cylinder of length L and area of cross section of area A. Hence derive the SI unit of critical resistivity. Okay, I think they are OR question mostly. Not sure, it is not mentioned in this question paper. The resistance of metal wire of length 3 meter is 60 ohm. If the area of cross section of the wire is 4 into 10 to the power of minus 7 meter square, calculate the electrical resistivity of the wire. State how electrical resistivity would be affected if the wire of part 2 is stretched so that its length is doubled. Justify your answer. Let's see the answer for the first part. So electric power is defined as the rate at which the electric energy is consumed or transformed into another form of energy such as heat or light. The relationship between power, potential difference and resistance can be derived using Ohm's law. So power is basically V square by R. Okay, therefore electric power can be expressed in terms of potential difference and resistance R as P is equal to V square by. It is not only Ohm's law, even Joule's law of heating can also be used because heat is also produced from electricity. So that is also a form of energy. So power consumed per unit time is also that can also come from Joule's law of heating. Okay, so power is equal to V square by R. Voltage is V is equal to 220 volt. Energy consumed is 11 unit. Okay, 1 unit is 1 kilowatt hour. So whenever we are trying to calculate the unit, it has to be in the kilowatt hour unit. So that is what's given here, right? It consumes 11 units of electrical energy. So electrical energy, unit for electrical energy is 11 kilowatt hour. Okay, in 5 hours. So 11 unit means kilowatt hour. So kilowatt hour means you have to multiply with 1000 to remove the kilo part, that is watt hour. Okay, now you have to multiply with for each hour basically it is consuming this much energy. For 1 hour it is consuming 11,000 watt. Okay, for 5 hours the power rating of the watt is 2200 watt. Okay, so the current drawn by the oven is 10 ampere. So to find the current drawn by the appliance, divide the power rating by the voltage supply. So definitely you can calculate the red hot. When the resistance of the oven is red hot, it is 22 watt. I think there is some one mistake is here. What is the mistake? Let me see. Calculate the power rating of the oven. Okay, power rating is easy to calculate. Okay, so voltage is given. Okay, it is consuming 11,000 watt hour energy in 5 hours. So this much energy, my mistake, this much energy is consumed in 5 hours. So the power rating will be 11,000 divided by 5 watt. Okay, this is the power rating. So if you cancel it, you will get 2200 watt. Okay, so this is how you have achieved this 2200 watt. You have to divide it by 5. Okay, total power consumed in 5 hours is this. Total energy consumed. Total energy consumed is 11,000. If you divide it with by 5, that means that much energy is consumed every second. That is the power rating. So power rating is 2200 watt. Okay, what is joules per second? So now we have got in joules per second. The current drawn by the oven is 10 ampere. To find the current drawn by the appliance, divide the power rating by the voltage supply. So voltage is given, power is given, you can calculate the resistance. Resistance is basically P is equal to V square by R. Okay, V is known, P is known, you can calculate R, right? R is equal to V square by P. Okay, and how to calculate current? Current is P is equal to VI, same thing but different equations. So I is equal to P by V. P is 20 to 100, V is 220 volt, 0, 0, so it will be 10. Okay, so current is 10 in this case. If you put the values here, 220 into 220 divided by 22,000, 2200, sorry, my mistake, 2200. So you will get 0, 0 cancel, 0, 0 cancels, this 22 cancel. So resistance is basically 22 ohm. Now when it is red hot means heater is fully operating, entire power is getting converted, so that means the resistance is 22 ohm. Now let's see the next part. So the relationship between resistance and the resistivity is R is equal to rho L by A, right? So this is the formula. Now SI unit of resistivity, you have to show the SI unit of resistivity from this equation. So what to do? You have to calculate rho, right? So rho equals to R into A into divided by L, right? From this equation, do the cross multiplication, you have to separate rho. Now resistance unit is ohm, area's unit is meter square, and length's unit is again another meter. So one of the meter will cancel, so you will get ohm meter. This is the SI unit of resistivity, as simple as that. Now next part, I have to go back to the question once. The resistance of a metal wire of length 3 meter, L is 3 meter, okay, resistance is 60 ohm, and area is 4 into 10 to the power of minus 7 meter square. Okay, so we will use the same formula. So rho equals to R, that is 60 ohm, area is 4 into 10 to the power of minus 7 meter square, and length is 3 meters. So everything is in SI unit, just have to put the values. So it will be 320 is a 60, so 420 is a 80, 80 into 10 to the power of minus 7 ohm meter. You can leave your answer here, or you can add just 1 0 to make it this ohm meter. This is also fine. Both answers are fine, both answers are acceptable answers. Okay. Now effects of stretching of resistivity, what will happen if you stretch the wire? Okay, electrical resistivity is material property and does not depend on the dimensions of the conductor. Stretching the wire will not change the resistivity, as it depends only on the material, not on the shape or size. So resistivity remains constant even if you change the shape, make it stretch the length to double, compress it to make the length half, the resistivity will remain unchanged. Resistance will change. Okay, resistance in fact will be 4 times, quadrupled, but resistivity will remain same. Okay, now 4 marker question. This is also very interesting question. Study the data given below showing the focal length of 3 concave mirrors A, B and C, and 3 respective distances of the object placed in the front of mirror. So now I have solved this question in my lecture. If you have missed, you can check it again. In which of the following above cases the mirror will form a diminished image of the object? So first of all, focal length is given. Focal length is given 20, 15 and 30. Okay, object distance is given 45, 30 and 20. Okay, so they are saying that with which of the above cases the mirror will form a diminished image of the object. So, and also remember that we are talking about concave mirror. Concave mirror can form all 3 types of images. enlarged, diminished, same size of the as the object. Also it can form real as well as virtual. Okay, in case of convex mirror, only only virtual image is possible, and that is always smaller than that object, always smaller than that of the object. But in case of concave mirror, all possibilities are there. So if the distance is more than 2f, if the distance is more than 2f, or that is the radius of curvature, then it forms a diminished image, right? Diminished inverted image. So in this case, if you see, this distance is greater than that of 2f or greater than that of the radius of curvature. Okay, this is greater than that of the radius of curvature, so definitely in this case you will get a diminished image. Okay, list two properties of the image formed in the case 2. So what is the case 2? If you see, so this is the focal length, and the object distance is basically exactly equals to 2f. Okay, so object distance is exactly equals to 2f. That means the size of the image is exactly same as the size of the object, right? So object placed at 2f, object placed at center of curvature, the image size will always be same in case of a concave mirror. So it is always same as the concave mirror, and not only that, it will be an inverted image, right? Real image, so real and inverted image. So properties are real and inverted and same size as the object. Same size as the object has to be mentioned. Same side as the object has to be mentioned, that is compulsory. Second point, you can mention real, you can mention inverted, or if you are smart, you can mention both real and inverted. It does not take too much time to write it, right? Real and inverted. So that is the second point. Now question number 3, what is the nature and size of the image formed by the mirror C? Draw a diagram to justify your answer. So in this case, if you see, the focal length is 30 centimeter and the object distance is less than that of the focal length. So object distance is less than that of the focal length means object is placed between focus and pole of the mirror. So concave mirror will produce a virtual, erect and enlarged image. So that is what you have to explain, and then you have to draw the ray diagram. An object is placed at a distance of 18 centimeter from the pole of a concave mirror of focal length 12 centimeter. Find the position of the image formed in this case. Okay, I think this is the OR question for the last part. Okay, let's see case number 1. The mirror, obviously mirror A. That was the answer. The object distance 45 centimeter is beyond the center of curvature. C is equal to 2f, 40 centimeter. When the object is beyond C, the image formed is diminished, inverted, and between F and C. Okay, properties of the image. This part is, last part is optional, but before that, whatever is mentioned, you have to mention that. Next is properties of the image in case 2, that is mirror B. The image is real and inverted. The image is same size as the object. So that's what I said. This is object distance is that of the center of the curvature. Obviously, this is compulsory. This point is compulsory. Point number 3, nature and size of the image formed by mirror C. Case 3, the object distance is 20 cm, is less than that of the focal length. So nature of the image is virtual, erect and magnified. Ray diagram, I have already explained it. You can see the ray diagram and draw original. They have given you the way to draw it. I have explained it multiple times, right? You can check those videos about ray diagrams. Okay, now, so let's solve the question. What was the question, by the way? An object is placed at a distance of 18 centimeter from the pole of a concave mirror of focal length 12 centimeter. Okay, find the position of the image formed in this case. So object distance is 18 centimeter, focal length is 12 centimeter. Okay, so object distance is 18 centimeter. Object distance by default is negative, since it's a concave mirror. Focal length will also be negative. Okay, now we have to apply the length equation, that is 1 by V plus 1 by U equals to 1 by F, or I have already done it, so I could have used the same equation. From here you can use V equals to UF divided by U minus F, right? We have already derived this equation. I can directly use that, but I have done this again so that if you are watching only for this problem, still you will not miss out. So U is minus 18, F is minus 12, U is minus 18, minus 12, that is equals to V. Okay, so that is V equals to, this is the style, 18 minus plus. Okay, so this minus and this minus cancels, so 18 into 12. Okay, and as you can see, it will be minus 18 plus 12. Okay, so it will be 18 into 12 divided by minus 6, so it will be 3, 6, 18, so it will be minus 36 centimeter. So minus 36 centimeter means real image. Okay, in case of concave mirror, okay, so after the image, this is object, this is the focal length, after the reflection it is forming somewhere here, so that is why it is a real and inverted image. That is why the image distance is negative. Right? What is the answer? The image is formed 36 centimeter front of the mirror from the pole of the concave mirror. So image is real, inverted and larger than the object. Okay, why it is larger than the object? You can calculate the magnification. Magnification is minus V by U. Okay, so magnification is minus V by U. So minus 36 divided by minus 18, minus cancels, it is minus 2. So magnification minus represents inverted and more than 1 represents it is a enlarged image, right? So these are the thing. So I hope you enjoyed today's lecture. It was short, crisp, and all the questions are very important. I will be back with the sample paper 8. Till then, bye.